Hi everyone and welcome to this tutorial session. In today's tutorial, we want to solve this math Olympiad question. We are given that a squared minus b is equal to 73 and b squared minus a is also equal to 73, but that the value of a is not equal to the value of b. So we're asked to find a and b. How do you go about this? This question is very related to the quadratic expression. So we are going to use our knowledge of the roots of a quadratic equation to be able to solve for the values of a and b. So in a nutshell, we are going to come up with expressions for a plus b that we will treat as the sum of roots, and then a times b that we will also treat as product of root, and then we'll fit all this information in the general quadratic equation expression. From there, we'll now be able to solve for the values of a and b. So a and b here are treated exactly like the roots of a quadratic equation. All right, without any further ado, let's start. So please watch the solution carefully. Watch the solution from the beginning to the end. We are going to get very interesting mathematical tricks. Okay, we are told that a squared minus b is 73 and b squared minus a is also 73. Let us call this one equation 1. Let us call this one equation 2. And we are also told that a is not equal to b. A is not equal to b. Okay. So we want to get expressions for a plus b and a times b. So the first thing that we want to do is to find this difference. Equation 1 minus equation 2. All right, this is equation 1, this is equation 2. So we're going to get a squared minus b for the left-hand side here, minus this other left-hand side, minus b squared minus a is equal to, we'll now do the subtraction on the right-hand side. 73 minus 73 is 0. This gives us, let's open the parentheses. We have a squared minus b minus times that is negative b squared, negative, positive is equal to 0. All right, let's put the squares together and the expressions that are not to the power 2 together. So we have a squared minus b squared. So we have a squared minus b squared, and then minus b plus a is equal to 0. So we got a squared minus b squared. If we rearrange this, we're going to have plus a minus b is equal to 0. We just took this one that way and took a this way. Now, this is a difference of two squares. If we apply the difference of squares identity here, we're going to have a minus b, a plus b, plus a minus b is equal to 0. Now we can see a minus b is a common term. It is found here and it is found here. Remember, it is like 1 times that. So when we're working, we'll know that it's 1 here. All right, so we'll factorize out a minus b. When we factorize out a minus b, we're going to have a plus b here, and then plus 1 is equal to 0. Okay, we'll factorize out a minus b. This is a minus b. It is 1 time. This is a minus b. We'll factorize it out. This is what we get. So now at this level, we have the product of two expressions giving us 0. Either this one is 0 or the other expression is 0. So either the first expression a minus b is 0. If that is the case, it means a is equal to b. But look at our hypothesis. In our question, we're told that a should never be equal to b. So this will just be rejected. that information is rejected. So we take the other one, or a plus b plus 1 is equal to 0. That therefore means a plus b will be -1. We can call this equation 3. So, but it's a very, very vital information that we need. You can see it's already a plus b what we need. We said that we're going to consider a and b as the root of a certain quadratic equation. So this will just be for sum of roots. So we have this major information, sum of roots, which is -1. Now we have done equation 1 minus equation 2. Let's take equation 1 plus equation 2. So we're adding. Let's add the left-hand side. We have a squared minus b plus b squared minus a is equal to 73 plus 73. That should give us 146. Okay, so we have, let's open the parenthesis. We have a squared plus b squared, and then minus b minus a is equal to 146. All right, we have minus minus here, so we'll factorize out the minus. We're going to have a squared plus b squared minus into a plus b is equal to 146. Now, if we take this one to the right hand side, this minus this expression, that will become plus the expression. So we're going to have a squared plus b squared is equal to 146 plus a plus b. And we'll carry all of this that way. Now, but what is a plus b? Remember that information there. Equation 3, very, very important. A plus b is -1. So we'll come and put -1 there. So it means we have a squared plus b squared is equal to 146 minus 1, which is 145. Okay, so there, a squared plus b squared is equal to 145. So we're saying a squared plus b squared equals 145. We can call that equation 4. All right, so now, now that we have equation 4, let's go ahead. Remember, our next important thing is to get the product AB. How do we get the product AB? If we know the value of this expression, then we will be able to come out with another expression with the product AB inside. So let's see what we get. Okay, the board is, we know that a plus b all squared is a squared plus 2ab plus b all squared. Okay, now from here we'll be able to come out with an expression for AB. This is 2AB. Okay, so if we take now a squared, so we can write this as a squared plus b squared plus 2ab. Okay, sorry for this inconvenience. Okay, so this is also written as such, but we want to get AB, so we'll take this one from the right hand side to the left hand side. So we'll get a plus b all squared minus a squared plus b squared will give us 2ab. We'll just simply carry this one from the right hand side to the left hand side. So we are getting to our product AB that we need for product of roots. Okay, so now we already know this value, a squared plus b squared. We know that value is 145, and we know a plus b. A plus b is -1. So from there, we'll be able to get our AB. So let's put those information there. So we're going to have a plus b. A plus b is -1. So we have -1 squared minus a squared plus b squared. A squared plus b squared is 145 is equal to 2ab. So this gives us 1 minus 145 is equal to 2ab. Okay, so what do we get? 1 minus 145 is -144 is equal to 2ab. We divide both sides by 2, so we'll have the product AB to be -72. Very, very important. So we have the product AB to be -72. Okay, we know our sum of roots, we know our product of roots. So what is left now is for us to put in the general quadratic equation. We put in the general quadratic equation. So sum A plus B is -1. Product AB is -72. All right. So we'll now put it in the general quadratic equation. It has the nature x squared minus sum of roots. Let's just write S. Sum of roots S subscript R multiplied to x plus product of roots is equal to 0. So a general quadratic expression will have that nature, which everybody knows. Okay, so we'll now put our information there. So we'll now have x squared minus sum of root is -1, -1 multiplied to x, and then product of root -72 is equal to 0. So this gives us the quadratic equation x squared negative become plus x, and then -72 is equal to 0. So this is the quadratic equation that we obtain from the information that we have, given those two major equations, equation 1 and equation 2. From this equation 1 and equation 2, we're able to bring out two vital information that we can now use the knowledge of quadratic equations to solve. Okay, so we obtain this quadratic equation. The roots of this quadratic equation will be the values of a and b. So what are the roots of this quadratic equation? We can use any of the methods. We want to use the quadratic formula, we can go ahead. We want to use factorization method, which is what I prefer. We can go ahead. So we need two factors of -72 whose sum is 1. Remember, if we collect our information, our A is 1, our B is 1, and our C is -72. You can use the quadratic formula. All right. So, but we need two factors for factorization method. We need two factors of -72 whose sum is B. That's whose sum is 1. Okay. So which are those two factors? It's clear. It is going to be +9 and -8. All right. So it's going to be 9 and -8. If we multiply 9 to -8, we have -72. And if we add 9 to -8, we're going to have +1. So these are the only two factors of -72 that respond to those two criteria. So using our factorization method, we now rewrite this quadratic equation. We now rewrite the quadratic equation. We rewrite this quadratic equation. In the place of 1 here, we're going to put -8 and 9. So we're going to have x squared, yes, minus 8 plus 9. Okay, x and then minus 72 is equal to 0. This is plus here. Okay, so this quadratic equation is rewritten in this manner. Okay, now let's open this parenthesis. So we're going to have x squared plus minus is minus 8 multiplied to x. You have negative 8x. And then we'll have what? Plus 9x minus 72 is equal to 0. Now we'll factorize the first two and factorize the next two expressions. In the first two expressions, we have x is common. So we have x into x minus 8. In the second expression, the second pair, we have the factor 9. 9 is common. So we have 9 outside into x minus 8 is equal to 0. Now the factorization process continues. We have x minus 8, x minus 8 is common. So bring x minus 8 out into x plus 9 is equal to 0. All right. So from here, we got again the product of two expressions giving us 0. It therefore means either the first one is 0. If that is true, it means x is 8. Or the second one is also 0. And if that is true, it means x is equal to negative 9. All right. So these are our two roots. Okay, the two roots of this quadratic equation, which we already called them a and b. So the x is 8, x is negative 9. So x can either be 8 or x can be negative 9. That means that what? That a can either be 8 or a can be negative 9, just like b can either be 8 or b can be negative 9. So we now do our conclusion. Our conclusion So our conclusion, we've gotten the two roots of those quadratic equation. So we are saying that a can either be 8 or negative 9. B can also be 8 or negative 9. So possible values are 8, negative 9, or negative 9, 8. Okay, so we can always go ahead and test to see if what we have is correct. Let's do a quick test. Testing. All right, let's take this first pair and see. A squared minus b, do we have 73? Question mark. So let's take the first pair. That means our a is that and our b is that. So let's put it there. We'll have 8 squared minus 9. Okay, so 8 squared is 64. Minus become plus. 64 plus 9 gives us 73. All right, so the left hand side agrees with the right hand side. So this information is correct. Okay, we take the other information. Now we also test the very first one. We have a squared minus b. So your a is negative 9. So you have negative 9 squared minus 8. So negative 9 squared become 81. 81 minus 8, we all know, is 73. So once more, this other information agrees with our first equation. The same thing can be done with our second equation. If you want to test with the second equation, you go ahead and you test, and you see that the results all agree. Okay, let's just take this one for the second equation. So we have b squared minus a. If we take this one, you see it will just be a repetition of what we had here. It will be negative 9 squared minus 8. Negative 9 squared minus 8, which is it, which we have here, negative 9 squared minus 8. And if we take this second information, we'll get the same expression when we're working with the second equation. So our verification shows that the values 8 and negative 9, or negative 9 and 8, are the values of a and b.